Hey guys, Mrs. O'Donnell here. Today we are talking about volume of spheres. Our goals for today are to find the volume of spheres. Don't forget to come to office hours if you have questions. I am here for you. All right, so take a minute, think about, check out what you see here. I want you to think about how many pennies. Okay, and I'll play this video. How many pennies do you think are in this pyramid? How many pennies do you think are in that pyramid? Check it out. All right. If you need another minute to think about it, pause the video. If not, we're going to go ahead and make your official guess. Make sure you're also thinking about, we're problem solving. So what kind of logical information would you need to be able to solve this problem instead of just making a guess at random? All right, so here's our answer. There are 287,820 pennies in that square pyramid. Okay, so if you want to read a little bit more, I snipped the sort of answer article where I got this from, so you can read a little bit more about that if you want to pause the video. Today we're talking about spheres. So a sphere is a set of all points in space that are given distance from a point called the center. The radius of a sphere is a line segment joining the center of the sphere and a point on the surface of the sphere, right? So your center is right there in the middle, and your radius is equidistant to all points surrounding your sphere. Okay, and then I've got a couple of examples of a sphere, right? If you've ever played pool or billiards, you have those, pool balls, and then you've got the Earth as a sphere. You've got these little magnetic clips that are in spheres. Okay, you might even want to challenge yourself. What in your daily life, what are some spheres that you come in contact with? I'm trying to think. If you kick cereal, those are made into spheres. What else? My kids play with soccer balls and volleyballs and baseballs, all that fun kind of stuff. Speaking of, I can hear one of the goblins did not go to bed. They're hiding by the stairs as we speak. Okay, so volume of a sphere. Recall, how many cones fill up a cylinder of the same base and height? So take a minute, challenge yourself, pause the video if you need to, write it down so you get that retrieval practice. How many cones fill up a cylinder of the same base and height? Then take a guess. How many cones do you think it will take to fill up a sphere? All right, so let's check out this video. We've got a couple things coming here. All right, so how many cones did it take to fill up a sphere? It took 2 cones to fill up a sphere, right? It took a sphere and 1 more cone to fill up the cylinder. Okay, so let's talk about how to think about this sort of volume of a sphere, right? So before we found the volume of a cone, right? The volume of the cylinder we knew was the area of the base times the height of the cylinder. And then we found the volume of the cone because we knew that was 1/3 times the area of the base times the height of the cone. All right, so now we have to kind of think about, we know that there are 2 cones in our sphere, right? So we want to think about our sphere. So we know that there are 2 cones, so we could theoretically just multiply our cone by 2 to find the height of our sphere. Unfortunately, a sphere has a little bit of a different, our sphere has a different shape than our cone. So it's not quite so simple since our sphere has this different sort of dimension going on than our cone does. Okay, so what we really need to do is we need to think about sort of a hemisphere, okay, because the area of the base, it's not really a base here. It's sort of, Cavaliere's principle. It's a cross section. So what we're doing is we're finding the area of this cross section, and then we have to think about the other dimensions. So we have 2/3. The area of our base is still pi r squared, but now we don't have just a height of a prism, we have to think in terms of radius. So we really just have another radius here. But if we're thinking about another radius, we're really only considering this half of our sphere, right? So we want to make sure that we're not just calculating the volume of half of a sphere, we need to calculate the volume of the entire sphere. Okay, so we need to actually take that and multiply by 2 again. So we have both halves of our sphere. So we have 4/3 pi, and then radius squared times radius is going to give us radius cubed. And that is your formula for volume of a sphere, 4/3 pi r cubed. All right, so now that we have our formula, let's test out using it. So let's find the volume of the given sphere and round to the nearest hundredth with our final answer. All right, so they're showing us the radius here is 6 centimeters. So we're going to just simply take that and plug it into our formula for radius. So I've got 4/3 times pi times 6 cubed. And then I can grab my calculator, right? Again, I love using that commutative property of multiplication to multiply things that are easier first, right? So I'm going to do 6 cubed, and then I'm going to take that times 4/3 and times pi. You don't have to rearrange the multiplication. You could just multiply straight in order. Just be careful if you're using a calculator that you would put those parentheses around your fraction. Okay, so I ended up getting 904.78, and that would be cubic centimeters, right? Because we are dealing with volume here. Volume is 3-dimensional. All right, let's try another one. If you're feeling confident, go ahead and pause the video. Test this out on your own. If you're not feeling quite as confident, you can go ahead and just work through it with me. All right, so here, what it looks like they're giving us is the diameter of the sphere. So what we need to think about is what is the radius. So we're going to cut that diameter in half. Our radius is 10 inches. I'm going to grab my formula. Volume equals 4/3 pi times 10 cubed. All right, I'm going to go ahead and chug through this. So 10 cubed, that gives me 1,000, times 4/3 gives me 1,333 and a third, and then times my pi button. I want to make sure and wait to round until the very end. So I want to keep as much in my calculator as I can for this problem. So I get 4,188 let's see here, we're rounding to the hundredths place, so that would be 0.79 inches cubed. And that's your volume for the sphere. All right, as you get more comfortable using your volume formula for your sphere, you'll be able to do slightly more complicated problems like this one. Here they're telling us the circumference is 24 pi feet. So how do we find the volume when they're not actually telling us what the radius is? So now we have to use our circumference formula, which is pi times diameter. So circumference is 24 pi. I have to figure out my diameter. So I'm going to divide by pi to both sides. I see that my diameter is actually 24. But really I need my radius, and I know radius is half of my diameter, so my radius is going to be 12. Now that I know my radius, which is just 12 feet, I can hop over to my volume formula and plug and chug through it. Plug in that 12 for my radius, go ahead and do 12 cubed, which is 1,728 times 4/3 times pi, and I get a volume that is 7,238 let's see here, this doesn't tell me what to round to, so I'm going to round to the hundredths place to 3 feet cubed. Same thing with this problem, right? This one says the volume of a sphere is 288 pi feet cubed. What is the diameter? So we could take that 288 pi, plug it into our formula, 4/3 pi r cubed. We're just plugging into our output instead of our radius, which is our input. And we're going to solve to figure out what that radius is, and then multiply 2 to figure out the diameter, right? So let's see here. I'm going to divide both sides of my equal sign by 4/3 pi. Divide by 4/3 pi. This is where, when you're solving, right, you do that reverse order of operations. Okay, so I don't have any addition and subtraction, so I'm going to get rid of my multiplication next. Thank you, Ella. Go to bed. And then I am going to, so 288, let's see here, pi divided by pi, that leaves me with 1 whole. 288 divided by 4/3 gives me 216 equals r cubed. Okay, next I want to get rid of that exponent, so I'm going to do the opposite, which is the cube root. If I do it to one side, I have to do it to both sides, so 216 raised to the power, the 1/3 power, or you could use that cube root button in your calculator. That gives me 6. So my radius is 6, which means that my diameter is going to be 12.